And with computer audio, where is this? There we are. Oh, had trouble seeing the screen. It was hidden a couple of places, so we'll get started here. So at the end of class, you asked for rapid fire 5, and instead of that, I'm going to just do a couple of problems on everything I remember working on in class today with you. And you don't have to do every problem. If you feel like, oh, I know how to do that, I'm good with that problem, then move on to something else. But these are the problems that I recall doing the most, and I'm sure I probably forgot something. I'm just getting up there in age. So number one, it's going to be the equation of a line through 2 points. Number two is writing differences as products. That was a special case we looked at. Number three is just multiplying a couple of binomials and adding like terms. Very similar to question 4. Number 5 is understanding the operations involved in an exponential calculation. Number 6 is how to find the maximum and minimum values of a quadratic. Number 7, combining some like terms. Number 8, solving a logarithmic equation. Number 9, squaring a binomial. Number 10, writing the equation of a line perpendicular to something written in standard form through a given point. So I'll just put minus 3, 5 here. All right, and I'm just going to shift my attention over to the other board and do the problems there, but you keep an eye on the order. I'll do them in this order. So if you know how to write the equation of a line through 2 points, you've been getting it right for the last couple of weeks, then you don't have to do that. But you pick and choose where you want to look. All right, so I'm going to do the equation of a line through 2 points, and I will practice that right now over here. Why don't we try through the points -1, 3 and 5, 20. All right, so you're going to pause the video, and I'm just going to continue working. And for those who are having a little difficulty with this, you want to rewrite it the way we looked at it in class: -1, 3, 5, 20, and hopefully that brings you back to what we were doing earlier today. So what does the equation equal? I'm going to just do it. You pause and you try. -1, so I got x plus 1. Get rid of that number. I want 3, so I write 3. Change in x from -1 to 5. I'm going up from -1 to get to 5. How much am I going up? 6 units. How do I get from 3 to 20? I have to go up 17 units, and that was that answer. Now we'll try another one. This time we'll go from about positive 130 to, let's go to 10, 19. Let's see what that becomes. You're pausing the video. All right, I'm seeing a 1 gets me to 30, so I'm looking at x minus 1 plus 30. I'm looking at how do I get from 1 to 10, go up 9. How do I get from 30 to 19, down 11? That's what you're trying to practice to do. Okay, so that's what we worked on in class. And you saw it another 2 times, and if we keep looking at it, I hope you own it. So, what did we talk about in class? Special numbers, area. That's what they represent. And the product comes from the square root. And those numbers we know. So 25 minus 4 could have been written as the sum of the square roots. The square root of 25 is 5. The square root of 4 is 2. Could have come from 5 plus 2 times 5 minus 2. We'll do it out. We know this is 21. This better be 21. 5 plus 2 is 7. 5 minus 2 is 3. By God, it's 21. That's the same answer written as a different method of getting there. All right, so now that we know that, can we apply that to more difficult situations like 9x squared minus 25y squared? I hope so. Pausing the video, and I hope you write the following. 3x plus 5y times 3x minus 5y. And we can see 15xy and minus 15xy cancels, giving us 3x times 3x, which is 9x squared, bumpity bumpity, and minus 5 times 5 is minus 25, and y times y is y squared. Yes, that product works. And we even made it far more difficult at the very end. We looked at 81 x to the 10 minus 25 y to the 4. We looked at that. We said, oh, you know what? Those are squares. They don't even have to be perfect squares. Working with the square roots. What's the square root of 81? 9. What's the square root of x to the 10th? X to the 5. And so we're going to do plus. Over here, we're going to do minus. Oh, what's the square root of 25? 5. What's the square root of 25? 5. It's going to be minus over here. Y to the 4th. Well, we said that's the same thing as this. Right? Y to the 4 over 2 is the square root of y to the 4th. That means square root. So all you got to do is divide by 2. And if you multiply this out, it comes back to that. All right, so that's a second problem that we worked on. Thirds, just multiplying a couple of binomials. We're looking at stuff like 5x minus 2 times 3x plus 7. And in class, we said, well, that's the same thing as 5x times 3x plus 7. Minus 2 times 3x plus 7. What does that become? It becomes 15x squared. We want to get to the point where we just see 15x squared right there. And then we got 5x times 7, which is 35x. Over here, we got minus 2 times 3x, which is minus 6x. We want to get to the point where we can see minus 6x and 35x. Let me do that without the other ones there. We want to see minus 2 times 3x, and we want to see 7 times 5x. There's the 7 times 5x. There's the minus 2 times 3x. And then, of course, we have minus 14. These numbers go together. Area statement, length of a line segment, which in this case is 29x, minus 14, and you're done. These are not like terms. You cannot put them together. If this was 29x squared, then yeah, you got, 44x squared, but it's not a square. You can't add that square area to this linear. It doesn't make any sense. All right, so let's do one more of those. You're pausing the video. I'm just trucking along. So let's look at 3x minus 7 times 2x plus 5. I'm seeing 3x squared, so that's the first multiplication. And if you need to, you write 3x times 2x plus 5 minus 7. Do it up here if you need to. Do it separately. Right, 3x times 2x is 6x squared, because you're doing 3 times x times 2 times x. And in class, we said you can rearrange that to be 3 times 2 times x times x. And I hope we're seeing that we don't forget to write that on the next test. All right, and 3x times 5 is 15x. I've done the 3x part. Now I have to do the minus 7 times 2, which is minus 14x, minus 35. And what do we do with that? We see 15 minus 14 is just 1x. I got 15 markers minus 14 markers. I got 1 marker left. And I hope this one lasts. So the final answer is 6x squared plus x minus 35. Okay, we practiced that in class. Some of you practiced that. All right, then we got very similar problem here. 7 minus 2, what I wrote over there, I might as well do here. And what did we say? What did we talk about in class? Pause the video, you're trying it, right? Move the 7 to the end. Right? At least we don't want to say 7. I mean, it was here. We don't do subtraction before multiplication. Right? So I see x minus 4 squared. What I see is x minus 4 times x minus 4. Right? And you can do the x times the x. You can do the x times the minus 4. You can do the minus 4 times the x. Minus times the minus plus. Many of you are ready for the shortcut. You know you got x squared. You know you got 2 of those multiplications. And you're going to square that. That last term's always positive. All right, so what do we have? Minus 2x squared plus 16x minus 32 plus 7. Well, the minus is bigger than the plus, but you know, we're at minus 32 minus 32 on a number line, right, is below 0, and you're adding 7, so you're going in this direction. And so hopefully you're saying minus 25 over here. Minus 2x squared plus 16x. That's what you're trying to do. We'll try another one. It's going to be on the test on Friday. I'm not hiding anything from you. You want a foundation, you got to do things right. Let's do 5 minus 2 times x plus 7 squared. Hey, I hope I got another marker here. This baby's running out. Cooking with gas. Here we go. So what do? Minus 2 parentheses. We're squaring this. X squared. 7x. That happens twice when you do this. And 7 squared is 49. And I'm not going to forget this 5. And we don't have to write a plus sign. We know 5 is a positive number. Some mathematicians don't write it, but it's addition. We do that last when we evaluate. Minus 2x squared. What a color this red is. Minus 14x minus 2 times is minus 98 plus 5. I'm heading towards 0. The more I add, like 50, 500, I get past 0. Right? So I'm going up. Going up means the negative is smaller. Negative 93 is what you want to be in. Right? So that's that one. All right, then we did a little work with exponents. And there are 3 operations with an exponent. There's powers. You already know that. There's powers. If you do 5 squared, you know what to do. Roots is a little harder to see. Right? Roots are a little harder to see. So if I did 5 to the 1/2, if I had a fractional exponent, that means the square root of 5. If it was a 3, that means the cube root of 5. Right? Which I don't know. I know what 5 squared is. I don't even know what the square root of 5 is. Calculator would tell me, but I know the operation in the denominator is all about roots. The inverse of powers. And then, of course, the minus sign is reciprocation. In other words, if I had 5 to the negative 1, we've talked about that as being 1 over 5 in class and the reasons behind that. I'm not going to do those again. They're in previous videos. Can't keep repeating those. That's all I do with my life is math. I think that's all I do anyway. But anyway, let's take a look. Let's take a look at 4 to the minus 3 over 2. There are 3 operations. So the question is, do you want to do 4 to the minus? Do you want to turn it into 1/4 to the 3/2? Do you want to do 4 cubed, which is 64 to the minus 1/2? Or do you want to do the square root of 4, which is 2 to the minus 3? Well, which one's easier to do? I'm putting my money here. That's where I'm putting my money. I really don't want bigger numbers. What's the square root of 64? 8 to the minus 1. What's the square root of 1/4? 1/2 cubed. What's 2 cubed? Well, I'm 8 to the minus 1 again. Question is, which one was easier? Working from 4 to 64 back to 8? Or going from 4 to 2 to 8? My money's over here. Okay, so what's 8 to the minus 1? 1/8. What's 8 to the minus 1? 1/8. What's 1/2 times 1/2 times 1/2? 1/8. All the same answer, so it doesn't matter the order you do things in. I'm going to look to see what's the easiest thing to do. All right, so let's try the following. Let's look at, let's look at 125 to the minus 2/3. All right, you're pausing the video. I'm telling you what I'm going to do. I'm going to do the cube root of 125. I'm going to do the cube root of 125. Boom, is 5. That operation's done. I got 5 to the negative 2. Well, we might already know that that's 1 over 25 just from the last problem. But I definitely am going to do 5 squared, which is 25 to the negative 1. And that means I'm putting the factor of 25 in the denominator once. And that gets me 1 over 25. All right, so that's how I do that. What if I had 9/4 to the minus 3/2? We pause the video. First thing I'm gonna do is flip it. I'm gonna do 4/9. That's one of the operations that's just out the window. Now I can either do 9 times 9 times 9 underneath 4 times 4 times 4, or I can do that operation. Hope you remember what that means, square root. I know the square root of 4 is 2, square root of 9 is 3, and then I'm asked to cube that. Well, I actually know how to do that without a calculator. 2 cubed is 8, 3 cubed is 27, and there's a little practice with that skill. Okay, moving right along. I don't know how much time I have left. I better check. How much time do I have? 10:40? I got 5 minutes before I have to get into class. I'll get this done, I think. Max and minimum values. I'm gonna apply 2x squared minus 12x plus 7. How do I find the maximum of this? Because it's a cup shape up. Minus b over 2a, 12 over 4 is 3. I'm gonna put 3 in, that gets me 18, that gets me minus 36, that gets me 7, gets me minus 18 plus 7, gets me minus 11. That's the minimum value I'm looking for. I'll do one more, do a maximum this time. Minus 3x squared plus 30x plus 10. Okay, that's cut shape down. That means I'm looking for that y value. Minus b minus 30 over minus 6 is positive 5. I put it in. That's minus 75 plus 150 plus 10. That's going to be minus a positive 75 plus 10. That's 85 is the maximum value there. All right, now I'm going to do the log here. I've only got a little time. I'm going to do number 8. All right, number 8. 4 log, let's say that this number is 2. 4 times 2 is 8. So let's make it base 3x minus 7. 8 plus 5 is 13. How do I solve that? I subtract 3, that gets me 8. I divide by 4, that gets me 2. I rearrange this. I've been saying inverse operations. I'm going to say rearranging. Right? That'll help you learn it quicker. So how do I rearrange log base 5 or 25 equals 2? How do I rearrange that? 5 squared equals 25. So how do I rearrange this? Pause and you're looking. 3 squared equals x minus 7. So 9 plus 7 is 16. Let's put 16, see how it works. 16 minus 7 is 9. What's the exponent put on top of the 3 to get a 9? 2 times 4 is 8 plus 5 is 13. Okay, I have to get to class. Let's do that perpendicular. And that's all the time I have, unfortunately, for you. I wanted to give you more than this. 5x plus 2y equals 20. Perpendicular through high there. Let's put it through high there. It doesn't matter what x and y I put there. You don't care about the constant. We talked about that in class. Always divide by a positive. You'll make fewer errors. So therefore, my original slope is minus 5 over 2. That's the original slope. I want it to go through high there. And minus 5 over 2 is the original. So my perpendicular is the negative reciprocal. So my new function is y equals, can you see that? Equals 2/5. That's what you worked on in class. X minus high plus there. I'm running out of room. I've got to stop this, upload it, and hopefully that's a little practice for you. Okay. Not as much as I wanted, but I'm out of time.